I'm Phil Bliss. I'm president of the ECA. I'm what I term a digital pioneer, which means I'm getting on in years. But I've had a great time over the past really 2.5 decades. I've been a strategic advisor to many established names that you know in the industry, as lots of emerging startups in the technology field and in the edge field, which obviously is part of that. Just a reminder, go to the site, look at Edge Careers if you're either an employer or a candidate. We do have a subscriber list of over 200,000 people, so it's a busy place and a great place to get your jobs out. Sorry, Tom, I'm jumping in, but I'm not going to spend much time today. For those of you that don't remember the invite that you clicked on, we're going to talk about meeting NIST guidelines for zero trust remote access to data specifically. And doing that, we have Tom Ward, who's the Vice President of Marketing at QNext Corp. He is also, a veteran of the industry, worked for the very large names that many people know, as well as, being there at the hub of emerging technologies, QNext Corp being the latest one of those. FileFlex Enterprise is an edge-based computing / operational technology that is zero trust data compliant, and in terms of the banner of FileFlex, the genius of zero trust data access, I'm going to hand over to Tom without further ado to dive into the topic today.
Thanks, Phil. So now we can see us. I'm just going to leave that screen on for a little bit, but I think that as a preamble, we have seen some confusion around what exactly constitutes zero trust. Every vendor seems to have a different perspective. And what I'm going to do is review with you what the National Institute of Standards and Technology, what they say zero trust is, as outlined in their special publication 800-207. I'm just going to give you a high-level review of all that.
Tom, just a quick dive in. I forgot to say, if there are questions as Tom is talking, just throw them into the question section. I'll be, like I normally will, interrupt and get as many as we can. And if we don't get them, we'll send the answers to everybody. Okay, Tom, sorry.
Oh, yes, okay. Absolutely. So, okay. When I'm on this presentation, I can't see the questions come in, so Phil's going to monitor them for us. I'm going to go through the publication 800-207, and then I'm going to review with you a typical architecture for zero trust. And it's going to be modeled after our architecture, but we use the same architecture as everyone else. There are some differences, but it's essentially the same architecture itself. So you get an idea of how this all works. And then I'm going to map those standards to zero trust data access, and in particular with our product as the example. It's called FileFlex Enterprise. Our product FileFlex Enterprise is a breakthrough solution. It was recognized by Red Herring and awarded as a Global 100 technology innovation. So let me come back here, and I'm going to now share. Hopefully the technology all works. Phil, you can see that screen?
Absolutely. Yep.
Okay, I'll go to the second screen. So what is NIST? NIST stands for the National Institute of Standards and Technology, and it's part of the U.S. Department of Commerce. It was originally established as a physical science laboratory, and it sets standards, is what it does, and from a wide range of technologies, from smart electric power grids to electronic health records to advanced nanomaterials to skyscrapers, if you can believe it, global communication networks, computer chips, and cybersecurity. So with cybersecurity, they address best practices and standards for usability, privacy. They include the Computer Security Resource Center, the National Cybersecurity Center of Excellence, the National Initiative for Cybersecurity Education, the Small Business Cybersecurity Center, and they have established standards and guidelines for cybersecurity, for privacy, for risk management, and information security. So if you're in that field, you know who NIST is, because you've been looking at their standards for your company and your organization before, particularly in government and education. And they have standards for zero trust. So how do they define zero trust? NIST defines zero trust, and they call it ZT, in short, as a term for an evolving set of tenets that move an organization's cybersecurity from today's existing paradigm that's based on static network-based perimeters, such as antivirus software, such as firewalls, such as OS patches, VPN patches, to a new paradigm that focuses an organization's cybersecurity on the user. Who is the user coming in? What are they doing? What assets are they trying to access? What resources do they want? So it focuses on each request, each user all the time. Instead of you're behind the firewall, you're okay. So NIST defines a zero trust architecture, a ZTA, as an architecture that applies those zero trust principles to the company and the organization's infrastructure and the organization's workflows. So workflows and your infrastructure is not protected by perimeters. It's protected by a policy engine that looks at the user, what they're trying to do, and what they're up to. Okay, so first of all, it assumes that there's no implicit trust granted to users simply because they're on a network or they're on the VPN. Simply because you're on the network doesn't mean you're not an adversary. We see that today all the time. And also, this is in response to today's work environment where remote users need to access company assets over the internet, or they need to access cloud-based assets that are not even on the company-owned infrastructure or the organization's owned network. They could be in a third party, for example, with Google or Amazon or Microsoft. And then second, it assumes that there's no implicit trust granted to a computer or tablet or smartphone based upon company ownership. So, the company doesn't just protect access from their own assets, from their own computers. They need to protect access from today's bring your own device workforce, BYOD workforce. So often, we use our own smartphones. I use my own smartphone to access the company databases. I use my own tablets or my own home computer sometimes. So they have to be able to protect that modern work environment. And the zero trust architecture is not focused on protecting just a network segment using a firewall or an OS patch or AV software, as the network location is no longer seen as the prime component in the security posture of the organization. So instead, a zero trust architecture uses the user's identity as the new firewall, if you want to say it, or that's what gets you access to different resources and devices. So that identity is authorized and verified for every transaction against a policy that will protect resources such as your assets, your services, your workflows, your network accounts. So NIST defines the goal of zero trust architecture is an architecture that prevents unauthorized access to data. That's what it's always about. It's preventing the bad guys and malicious actors from getting access to things they shouldn't have access to. Example was just recently a Tesla was they hired a new employee. He immediately started downloading documents he shouldn't have had access to, but he did, and he got away with them all. It was a mess. So you want to prevent unauthorized access to data, and you want to make that access control enforcement as granular as possible. And the standards for zero trust architecture, they've outlined them in a document called the Special Publication 800-207. You could go to it yourself, Google it, and read it yourself. And it defines zero trust architecture in terms of the following basic tenets, which is what I'm going to go through with you right now. The first is that all data sources and all computing devices are considered resources. I kind of went to this in the preamble, but that's to address any wrong assumption that organizations only need to protect their company-owned devices. They got to protect everything, including the BYOD devices, okay? And that all communication is secured regardless of the network location. So just because you're behind the firewall does not imply you should be trusted, okay? Organizations need to protect information even if it's accessed over the internet, or if it's located on cloud-based assets, or if it's not even located on their own infrastructure. It could be with a third party. So they have to be able to protect that information no matter where it is and control it. Third is that access to individual enterprise resources is granted on a per session basis. So, you go in, you get what you need, and you leave. You come in again. You're not automatically authorized. You got to go through every request, and you have to be evaluated before any request is granted. And when it is granted, it's granted with least privileges needed to complete the task. So if you need to, access to a particular file that's in a particular folder, that's in a particular device, don't get access to the whole device or the whole folder even. You only get access to what you need. And once you're authorized, that authorization does not automatically grant you access to other things. So I have access to that folder. I don't have access to anything else. And access to resources is to be determined by a dynamic policy. So what that means is that there's a policy engine involved in this, and that policy can be assigned to a user. So for example, I as a user may be allowed to access anything in a particular folder, whereas Phil may be only allowed to access certain files. Or I may be able to access those things but never share them, but Phil can share them. Or I can never share them, but Phil can only share them with restrictions. He can only share them in view-only mode or full rights. So it's assigned to a user dynamically, and that can change at a moment's notice. And every user is different. It can be assigned on a data asset like a drive or a folder or a file that can have specific permission sets around it, or an application. And it can be done on a user-by-user basis, an asset-by-asset basis, or an application basis, or any mixture of that. And then even with that, least privilege principles need to be applied to that access, okay? The next is that the enterprise monitors and measures the integrity and security posture of all owned and associated assets. So no assets inherently trusted. And the enterprise evaluates the security posture of an asset when evaluating a resource request. And then it should be applying patches and fixes as needed, or deny service if the asset has been subverted. All resource authentication and authorization is dynamic and strictly enforced before access is allowed. So there's a constant cycle of authentication and authorization of the user identity for all user transactions. So there goes through user authentication for everything. And they strongly suggest that you use multi-factor authentication of some kind to authenticate that user. It's not just a username and password that could be obtained through a phishing attack, for example, and exfiltrated from your company, from your users. So that you go through a more robust user authentication. And the enterprise collects as much information as possible about the current state of assets, the infrastructure, the communications, and it uses that to improve its security posture. So there's a cycle there. There's a feedback cycle, so that the architecture itself authorizes and verifies all transactions, and organizations should use that information that it gathers to improve policy creation and enforcement. So this here, if you stay with me thus far, I went through it pretty quickly, but that's a basic high-level understanding of a NIST standards and of a zero trust architecture. And this diagram here shows you a typical zero trust architecture. In particular, it's our product, but it's the same. I've looked at a number of these architecture diagrams from other zero trust products. They're all basically the same. And there are some differences, but they're the same in the fact that they have where's my cursor? They have a policy server, and they have a connector agent. And so what you have here, the differences is that we provide access directly to files and folders over here, whereas others would provide access to a device or a segment of that, or to an application, okay? So I could spend a long time on the diagram, an hour probably, and how security is achieved, but we're not going to go through that. So I'm just going to give you a high-level overview. So on the right here, you've got a typical hybrid IT infrastructure of an organization. You've got on-premises storage, servers and NASs and server-attached storage. You may have a corporate data center. You may have remote locations, and you may have infrastructure of service providers such as Amazon or Azure or Google Cloud. Okay, and then on the left, you have the users that want to access that information. and they might be trying to use it from a remote computer. It might be company owned, it might be their own, a tablet or a smartphone. And they're connected through a server, okay? And the server takes that request and establishes an encrypted file transfer channel, okay, or a microtunnel. It's an encrypted SSL microtunnel to that request. So you would look at the microchannel like a driveway to a house versus, say, a VPN gives you access, but a VPN is like an interstate highway to the entire infrastructure. Now, I understand also with VPNs, you can put on levels of segmentation and privileged access management. For the most part, though, you're getting into the infrastructure, and you maybe even have access to everything, but you can see them. Okay, so think of a microtunnel like a driveway versus a VPN like a highway. And the microtunnel goes directly to the files and folders or the asset that's being accessed. And then you can think of that server like a switchboard operator. So in the case of zero trust data access, that switchboard operator checks that user against the policies and then connects them to the files and folders when they have permission and access is all okay. So with a zero trust network access product, they would connect users to a network segment or to an application, whereas we would do it directly to a file or folder. The server also acts like a bank teller. And that's my favorite analogy for zero trust. When you go to the bank to get some money, you're not allowed to go to the bank vault and get it yourself. You have to go to the teller. And then the teller verifies your ID. They tap away at the computer screen to see if you have the money in your account and whether you're allowed to have that money. And so the same way the server verifies and authenticates the user and then checks that request against the policies and permissions for that user. So the micro channel goes directly to the connector agent, and that connector agent also acts like a teller for a bank vault. So if you want money from a bank vault, typically whenever I've gone, the teller is not allowed to go even to the bank vault. He goes to another teller, a vault teller, and that person then goes and gets anything that's in the vault. Even the teller's not allowed in there. So there's another employee who's authorized to access that vault. And in the same way, that connector agent would take the request from the server and act like an intermediary or as a proxy to go get the information and bring it to you. So this diagram, I've got a couple of circles here that show the differences between traditional network-based perimeter defenses, which is typically what happens through a VPN. You get into an implicit trust zone, which could be the entire network. And I do understand that you can apply some microsegmentation of that, and you can apply privileged access management to it. But for the most part, most users get into a zone there, implicit trust zone, which is quite large, and maybe they can't access, this server, but they can see it. They can see things, or this folder, but they can see it and they can ping it. Okay, and then the second circle here shows a zero trust network access technology, and that segments the trust zone down to a smaller segment, like a device or an application. And these two circles, this diagram here came directly from a blog that NIST ran. And so we called NIST and we had a conversation with them, and we said, hey, we really think there should be a third circle. And they agreed. And the third circle would be we call zero trust data access, which brings that trust zone right down to the file level or to the folder level, to the very smallest implicit trust zone for data access, not just network access or application access. So that's what zero trust data access is in a just a very high level. So now how would zero trust data access meet NIST standards? In particular, we use our product as the example. So the first is that it would consider all data sources and computing devices as resources, as the first two premises of the NIST document goes through. And it would consider that access and sharing of all data sources, whether they be on premises, such as on a server attached storage or network attached storage, or whether they be cloud hosted, such as a private cloud, a public cloud, or enterprise grade cloud, or whether they be infrastructure as a service provider, such as Microsoft Azure, Google Cloud, Amazon S3, or even a SharePoint, self-hosted SharePoint or cloud Microsoft-hosted version of SharePoint. And it would protect that information from a company-owned device or from a BYOD device that's privately owned by the users. Second is that it secure all communications regardless of the network location. And it would do that using SSL encryption or EAS encrypted hybrid point-to-point encryption. Ours uses a hybrid point-to-point system where we don't just encrypt the data tunnel, but we also encrypt the data stream inside the tunnel. So that would protect it against any kind of intercept or snooping because it's then encrypted right from source to destination. And no files are stored on the server, so that will reduce the threat surface. And encryption keys would not be generated in system memory. They would be generated either inside of the PKI server, or they could be generated inside the secure SGX enclaves of the Intel processor. And that would protect transmission even on a system that's compromised by malware. And the double encryption I went over here protects you from source to destination. Third is it would grant access to enterprise resources on a per session basis. So just because you're behind the firewall doesn't mean you can do anything you want. It continually authenticates and verifies, then grants access to information. And it uses an exchange of anonymous tokens so that no credentials are ever stored on the server by the provider, by us. And those tokens would then protect your device credentials. They're actually stored in the connector, okay, and behind your firewall. And then access to those resources granted only with the least privileges needed to complete the task. And that's designed to prevent any malicious lateral movement. So once you have an authorization, you don't get authorization to other resources, and you can't access the whole storage infrastructure. The connector would act as a proxy to fulfill the request, go get it, encrypt it, and send it back to the user, and it's all abstracted from the infrastructure. So direct access to resources is never permitted. You can't go in and get it yourself through this platform like you would if you're in the office and on the network, okay? So you have to log in, be authenticated, go against a policy, and then the proxy goes and gets it for you, okay, according to whether you have permission or not. Access is granted according to dynamic policies. So IT administrators can use the management console to set access and sharing policies that can be determined on a user by user basis, or a group basis, or a storage basis, location basis, even to folder and file level granularity. And it minimizes the implicit trust zone to the smallest granular level of files and folders. So an administrator can make a selected device, folder, or files view only. It can do it with restricted permissions. You can only look at it. You can't share it, or you can't download it, or it can allow access unrestricted in any way it wants to. And it can set those sharing options so the downloading of shared content is not permitted, and that unauthorized copying or sharing of files can be prohibited both by the user, so they're sharing it and say, okay, this can't be downloaded. They can set those permissions, or by the administrator. This whole folder, let's say it's a HIPAA healthcare situation, and there's folders of stuff that's confidential or private, and they can't be shared with anyone. But you can look at them. The doctors can go look at them and access them, but they can't share them. Fifth is that we provide a detailed activity log, and this is important for any platform, because you're obviously granting access based on a policy engine. You know what's going on, and you can make a log of that. Yeah, and then you can keep that log and export it. You can view it whenever you want to, and view it by user or by activity or by a device, even for inactive activities like public cloud. So let's say you allow access for users to access their Dropbox account. Well, if they're doing it through the platform, then you have a whole ability to audit and look at what they've been doing. Okay, so the activity log can be then imported into your SIM system and using common import protocols. And then all use resource authentication authorization is dynamic, strictly enforced before access is allowed. And that means that you have user authentication. And the first that we put on there is device authentication. So IT administrators can put that device authentication in place so that only authorized devices can access company resources. So even though you have the username and password, if that laptop or if that smartphone or if that tablet hasn't been authorized by IT, they can't get in. And it can be, by the way, it doesn't have to be company owned, it can be employee owned, but they would authorize devices. And that acts like a type of two-factor authentication and protects against phishing. But also we support multi-factor authentication and two-factor authentication, and we support U2F device keys like YubiKeys, and they also protect against phishing and session hijacking and man-in-the-middle and malware attacks. We also support single sign-on, and we support the security assertion markup language SAML. It's an open standard that most people use, so we can support all the popular single sign-on packages. And then we will prohibit sharing to unauthorized users. Sharing is done and consumed in-app. So you don't get a link that you can then, a user doesn't share a link that then can be posted on social media to the whole world. It has to be open in-app through the FileFlex app. And then, because then we authenticate the user, make them go through the two-factor authentication or the device authentication or the MFA or the YubiKey authentication. So we don't allow open links that can be forwarded and shared on social media. And we even restrict administrator access. So even administrators cannot use FileFlex access to access any restricted information beyond what their own permission levels permit. And all administrator activities are logged. And then we would support the LDAP and the Active Directory and the Azure Active Directory. And so that means when a new user is added, they automatically only get access to storage as allowed by the Active Directory. Now, the IT administrator can make exceptions to that inside the console, management console, but that's would be automatically done. And when a user is deleted, say they quit or they leave the company, when they're deleted from the Active Directory, they instantly lose access. They lose access to any storage through FileFlex Enterprise, and their file sharing is turned off. And that reduces the risks that are associated with timing delays or human error that having to manage deletion as two separate actions in two separate silos. Okay, so we control that. So in addition to the zero trust, the typical standards from NIST, we would support branch offices, a multi-domain organization, satellite locations, a data center, multiple domains. And we do that all from a single pane of glass. And we provide not only just access and sharing to that, but we provide complete file management between it all. So you could, for example, take a file or a whole set of files on your Google Cloud and migrate it all over to your Azure cloud. You know, it's a great migration device, or from your PC and move it into Azure or to NAS or to a server attached storage, or from your SharePoint. SharePoint's probably the most popular one. You get that, and we access, because you establish those microchannels directly to a connector agent when it acts like a proxy. We could access SharePoint on premises, and you could access it and share it. As far as I know, we're the only application that allows you to share on-premises implementations of SharePoint. Or you can create virtual data rooms, stuff like that. Okay. So the second is we support remote access and sharing of contractors and gig-based workers. So as we go to this distributed workforce, especially as everybody's home now, working from home as I am today, we support all of that. Their location just doesn't matter. And you can add users. You don't have to make them paid subscribers. You can share with as many people as you want. They can all have access to your data room or to your SharePoint files that you share with them to external parties. Okay, and if they are a gig-based worker or a contractor, you can give them, IT can edit their permissions and give them just access to the things that they need and nothing else. You don't have to give them access to a whole VPN or to your SharePoint, make them a SharePoint user, stuff like that. Okay, and we support collaboration with those external parties, and it's all controlled by IT. So your external parties can remotely edit and replace files, including your gig-based workers and your contractors, or any just a partner of some kind. that needs to be involved, or an agency person or an outside person that you need to collaborate with. That's all supported. The platform is very versatile and flexible. When you move to this kind of a platform, you have incredible control over what's going on in your organization. IT has visibility over everything, control it all. I can't even go into all the features here because this kind of ends the presentation. But you can even monitor things like their bandwidth consumption. And you can see if there's anything abnormal going on. Somebody's downloading a lot of files, it gets flagged, you can see it. Or other users or paid users are never using it. You can see they're not consuming any bandwidth. So then you could contact them and then delete their license if you need to. So you're not paying for something you don't use. It's very, very good that way. So Phil, I'm going to turn it back over to you. And if you guys want a free trial or want to know more about our product in particular, and hopefully I gave you a good high level to NIST and how it maps, you can contact us in the question box there and leave some information, or you can email me at tomw@qnext.com. So tomw@qnext.com.
Yeah,
Okay,
thank you very much, Tom. And just before we close, just to let everybody know, we will be posting this and letting everyone know that it's available in case you want to kind of review it and go back to certain points on it. So thanks, everyone. Tom, thank you for taking the time, and look forward to the next session. Okay.
Thanks for inviting me, Phil. Thank you.
Okay. Bye-bye.